Okay, so let's talk about the linear ordinary differential equations. So a linear ordinary differential equation is of this form. Dy over dx is equal to plus dy over dx plus a function of x times y is equal to another function of x. Okay, so here you can see that this is the standard form of the linear ordinary differential equation. So you can see that this equation is linear in terms of y. Okay, so that's why we call it as a linear ordinary differential equation. So when dy over dx plus px over y, so in the standard form the coefficient of dy over dx should be 1. So if you get an equation in which you have some other value over here, then you have to divide with that value and then to make it to make that equation in a standard form. So this type of ordinary differential equation can be solved by using the integrating factor. So the integrating factor mu is exponent, that means e to the power integral of this function px. Okay, dx, integral of this function. So when we use this integrating factor, then the left hand side of this equation we get as mu times y prime from the product rule. Okay, so the after when so it means that when you multiply this original equation, the left hand side becomes mu times y prime, the right hand side becomes mu times q of x. Okay, so this can be solved because mu y prime, if you take the integral, so it will be simply mu times y, and on this side you will have to take the integral of this mu times qx function. Okay, so in this way we will get the solution. So let's see it with the help of an example. So let me take the first example. Dy over dx is minus 3y is equal to 0. In fact, this is a separable equation, so we can just use the separation of variable method to solve it, but let's do it with the help of this technique, integrating factor. So in this case, first of all, we will find the integrating factor, which will be exponent. So this will be the px function. So px function is minus 3 dx. So here simply the integrating factor will be e power minus 3x. So now if I multiply this by e power minus 3x, so it will be dy. Okay, and then I also multiply by dx, so it will be 3 e power minus 3x y and then dx, that is equal to 0. So the equation will become like this. 0 multiplied by e power minus 3x will be the same. So now we have to identify what is this left hand side of this equation. So let u is equal to e power minus 3x, and v is equal to y. So what will be du? Du will be minus 3 e power minus 3x dx, and dv will be dy. So substitute these values over here. So e power minus 3x is u, and dy is dv, and minus 3 e power minus 3x dx is du. So this value and this is a du. So it will be du, and then y is v is equal to 0. So what is this? U dv plus duv. So it is the formula for the product rule for two functions. So this means that this is actually the differentiation of this u times v. Okay, so we can represent it like this, so which is equal to 0. So if you integrate it, so then it will become uv is equal to integral of 0 is a constant. So what is u? So now we can put the value of u, e power minus 3x, and v is equal to y is equal to c. So which will give us the solution y is equal to c over c e power 3x. So this is the solution. Okay, so this is how the process works for this method. Take another example. This is the same as previous one, dy over dx minus 3y is equal to c, but only difference is that instead of 0 over here we get 6. So in the previous case for minus 3y we got the integrating factor as equal to minus 3x, okay, for this. So the integrating factor will be same because this equation is in the standard form, and the integrating factor will be e power minus 3x. So what we will get over here, I will not repeat this over here. Ultimately, by the integrating factor, we will get a term on the right hand side, on the left hand side will be equal to e power minus 3x, which is the integrating factor, times y prime. And then on the right hand side it will be 6 times e power minus 3x, because we have to multiply throughout by the integrating factor. So the right hand side will be 6 e power minus 3x. So now we can integrate it. So if I integrate it, so it will be simply e power minus 3x y, and this will be 6 e power minus 3x and minus 3 from the chain rule plus c. So now we will get, so I will divide throughout by e power minus 3x, so y is equal to minus 2 plus c e power 3x. So this will be the answer. Okay. Okay, so take another example. So this was example 2, previously it was example 1. So take another example and let's solve one more problem. Example 3. Let's do x dy minus x dy over dx minus 4y is equal to x power 6 x power 6 e power x. Okay, so this is the linear ordinary differential equation, but it is not in the standard format. So for the standard format, I have to divide it throughout by x. So it will be dy over dx minus 4 over x y is equal to x power 5 e power x. So this will be our p of x function, that is minus 4 over x. So the integrating factor will be the exponent integral minus 4 over x dx. So exponent, it will be minus 4 log of x. Okay, it will be exponent log of x power minus 4. So exponent and log are cancelled out, so it will be simply x power minus 4. So the integrating factor we got will be x power minus 4. So now this equation will become x power minus 4 times y prime will be equal to x power 4 into x power 5, that will be x e power x. So for the you can do the integration by parts on the right hand side. Left hand side will be x power 4 minus 4y, and the right hand side we will do the integration by parts. So you can use the DI method for the integration by parts. X e power x, 1 e power x, 0 e power x. So plus minus plus. So this integration will be x e power x minus e power x, and then plus the constant. So in terms of y, this value will be x power 5 e power x minus x power 4 e power x plus cx power 4. So this will be the answer. So this is the answer, and this answer we obtained by multiplying both sides of this equation by x power 4. So it will be x power 5, x power 4, and then x power 4. So this is the solution. Okay, the next example or next problem. X square minus 9 dy over dx plus xy is equal to 0. So this is not the standard form, so we need to divide by x square minus 9. So it is x over x square minus 9y and then 0. This will be 0. So this function x over x square plus 9, this is our px function for integrating factor, and the integrating factor is exponent integral x over x square minus 9 dx. Okay, so we need to find the integral. So this integral is easy because x square, it's a chain rule value, half of that chain rule value is present over here. So suppose v is equal to x square minus 9, so dv will be equal to 2x dx. So x dx will be equal to dv by 2. Okay, so we can use these substitutions in over here. So exponent integral 1 over 2, that means so for example x dv will be equal to dv over 2, so dv over 2 divided by x square minus 9. X square minus 9 is v. So now dv over v, that means 1 over v, this is the okay, the remaining part in the next video clip.